Salutations, today we're going to be doing the 2017 AMC 10B problem number 15. Rectangle ABCD has AB equals 3 and BC equal to 4. Point E is the foot of the perpendicular from B to diagonal AC, and we're looking for the area of triangle AED. So this is a geometry problem. What does it mean? More importantly, what does it look like? So since I'm drawing this digitally, I would probably mess up the diagram. So here is a digital diagram I got off of the Art of Problem Solving website, which was what I drew when I tried to solve this problem on paper. And point E being the foot of the perpendicular just means being where the perpendicular touches, just shows where the perpendicular from point B touches diagonal AC. That would be point E. And we're looking for the area of AED, which is this area over here, which is shaded by me. So now, to find the area of a triangle, we need two things. One, its height, and two, its base, or, well, length or width or whatever. So we can find the height by drawing in another line, which would be this one. Well, not this one. Which would be this one. And that is the height because it would be from here to there, the highest point of that triangle. And now you will notice, wait a minute, this is the same as this. So what is that? Well, notice this is a 3, 4, 5 triangle, right? It's a right triangle because it's in a rectangle. So AC is 5. AC is 5. So now, the area of ABC, area would be 3 times 4, 12 divided by 2 is 6. So now 5 times what is 6? Now that x, well, actually no, 5x would be 12. Because we're looking at, well, what if it's a rectangle, and then we would divide that by 2, so x would be 12 fifths. It is because 5 times 12 fifths is 12, and divide by 2, that's 6. So this is 12 fifths, and so is that 12 fifths. So now we have our height, 12 fifths, wonderful. Now how do we find the base? Like how do we find this? AE. So we can do this by looking at this triangle over here. Triangle ABE. And now here, it's also a right angle, and we can see, wait a minute, there's some similarity here. Notice this angle and this angle and this one, and well, okay, it is just a rule that whenever there's an altitude dropped from the 90-degree corner of a right triangle, the other two triangles would be similar to the bigger original one. So now which sides in this triangle correspond to the sides in this triangle? Well, let's think very carefully about the angles and the sides. So let's see. There's the short side, long side, 3 to 4. That's the ratio. So 3 to 4. And then we would have 3 to 4. So there's the 4 side, the side that is 4 compared to this one, and then So this side would be 9/5 because 3 times 3 and 3 times 4. And this is also 15/5. 15 is 3 times 5. So now we have that. Wonderful. We have the base. So we have this base and this height. Now we just have to solve for the area. 9/5 base times 12/5 the height times 1/2 because it is a triangle. And now 12 and 2 cancel out is 6, so it becomes 54 out of 25. And that is as simple as it gets because there are no more common factors. And even though this looks very hairy, wait a minute, it's an answer choice. 54/25, that is indeed our answer, and we are done. Triangle AED has an area of 54/25.